In our unit, we are working with our quadratic functions. So what we're going to start with is going over the graph of a quadratic, which we have actually done before, but we're going to do a little bit more with it this time. First thing we need to know is your standard form for a quadratic function. Pretty much everything we're going to be doing in this unit, you need to first put your quadratic in standard form. What that is y equals ax squared plus bx plus c. That is our standard form. The x squared term comes first, then your x, and then your c. We did do this last unit. You had to put everything in standard form. Your largest degree always goes first. So our largest degree here is the x squared, and then your x, and then your number afterwards. Our parent function, this is something we're going to be dealing with a lot in this unit. We have also talked about it a little bit before. Your parent function is your most basic form of any function. So for our quadratic, our most basic quadratic we could possibly have is your y equals x squared. So our parent function for our quadratic is just that, y equals x squared. That's the most basic one we could possibly have. Then the graph is a parabola shape, which is just a U shape to it. We call it a parabola though. So the function itself is a quadratic. The shape of the graph is a parabola. So when we're graphing our quadratic functions, to review this a little bit, you always need a table of values. And you got to have at least 7 points on that table. You need to look for a pattern in the y values. That's how you figure out which part of the table you want to actually copy down to help you make your graph. And then sometimes an interval is given to you for your domain. For example, they would state it like this. -2 is less than or equal to x, which is less than or equal to 4. So what that is telling you, in the x side of your table, you would use -2 to 4. And then that tells you where to look in your calculator to get the rest of the values, to get your y values that go with it. So then you're going to connect your points and make a smooth curve. We don't use rulers for these. It's a U shape, so there's going to be a curve to it. There's not really a straight line to it. If a domain is given, you do not include arrows on the ends of your graph, because all they want to see is just that part of the graph from -2 to 4. They want to see nothing else. So you don't put arrows on it. If they do not give you a domain, then you do put arrows, because that graph goes on forever. We're just looking at a small portion of the graph. So let's actually draw one first, and then we're going to go through and talk about these different parts up here. So they want us to graph x squared plus x minus 6. So we're going to need to have to copy our table of values down. So let's set up our table. We got our x, and then we got our f of x, because it wasn't a y equals equation, it was an f of x equals equation. So in your calculator under y equals, I want you to type that in, x squared plus x minus 6. Under your y equals, we should have x squared plus x minus 6. So once you have that typed in, push the graph button so we can look at the picture. My window's a little messed up. Is anybody else's windows messed up a little bit? If it is, push the zoom button, which is in the middle up on the top, and then the number 6, and that'll fix it for you. So if your window doesn't look like this one does now, zoom, and then the number 6 will fix it. So here we have our nice smooth curve to it. It's got that little U shape. That's what we call our parabola. So let's look at our table. So as I said in the notes, you need to find a pattern in your calculator. So what that pattern means is you got two numbers that are repeated. You got the 14 here and you got the 14 down there. And then you got the 6 and the 6, and then the 0 and the 0, and the -4 and the -4, and the -6 and the -6. So the numbers are repeated. That's the pattern you want to look for. So let's copy from -4 to +3 down in our table. You always got to find that middle of that parabola, which is why we look for that pattern. That pattern helps us find the middle. So I got 6, 0, -4, -. So once you have your points written down in your table, go ahead and plot them. Do not connect them just yet. Just go ahead and plot them first. Between the -1 and the 6, it kind of looks like it levels off. But if we look at the picture of our graph, does it actually level off? No, it's going to curve down just a little bit. So when we connect our points, we're going to connect them, as I said, in a curve, and you want to go down a little bit and then hook up and hit the point at 0. You don't want to make a straight line piece there. It's going to go down just a little bit and then connect back up. Then again, we label it f of x equals x squared plus x minus 6. You always got to remember to label your graphs. So let's go ahead up here, take a look at our different key features, as we call them. Roots or zeros. I use both those words because they use those two words interchangeably. They mean the same exact thing. It's just sometimes they call them zeros, sometimes they call them roots. Don't let that confuse you. It's the same exact thing. It's your x-intercepts. So if we look at this graph here, your roots or zeros are where your graph cross your x-axis. So we have 2 of them here. I'm going to label this as root 1. That one is root 2. What are the values at those 2 points in times? -3 and 2. So the way we write our roots is x equals -3, x equals 2. Some people may tell you you can write them as a point. Please ignore them. That's not the way the Regents wants to see them. They want you to write them as x equals -3, x equals 2. Next thing, our axis of symmetry. You guys know what it means to have symmetry? Yeah. What does symmetry mean? Yeah, same on both sides. So our parabolas, they have symmetry. This one is actually going to be kind of halfway through. Our axis of symmetry is this imaginary line that goes right through the middle of the parabola, and it's the same on each side. If I were to fold my piece of paper on that axis of symmetry, it's going to be the same on both sides. It'll line up. So they want you to draw that imaginary line going right through the middle. Ours goes through at like -0.5 on your x-axis. It doesn't go through right at -1. It's a little over. It doesn't go through at 0. It's a little over. I labeled it as AOS. That's what I always shorten axis of symmetry down to, instead of writing the whole phrase axis of symmetry every single time. As I said, this time around our axis of symmetry is at -0.5. It's not always going to be a decimal. A lot of times it's going to be a lot easier for you to find, and it'll be right through the middle out of a whole number. But again, your axis of symmetry has to be written as x equals. It is a line. It is an imaginary vertical line. It needs to be written as a line. So you need to have the x equals for that. Next part is our vertex, which is also known as your turning point. Your vertex is where the graph changes from being increasing or decreasing to the other one. So our vertex right down here, I'll label it as V. For our problem right now, our vertex is negative 0.5, negative 6.25. On a different example, I'll show you how to find it in your table. It's a lot easier, but this one isn't a good example for that. And then our average rate of change. We talked about average rate of change. We did this back in our function unit. That's just your slope formula. Average rate of change is just the fancy name we use for it. You're just finding your slope between 2 points. So our slope is the change in y over the change in x. Here's the definition that makes people freak out a little bit, but there's no reason to freak out. F of x, we always said, is the same as what? Y. So this is really like y2 minus y1. If you change f of x back to y, they're the same thing. So it's just your slope formula, y minus y over x minus x. Let's find for negative 4 to 0. This is one way that they could write it. They want you to go from when x is negative 4 to when x is 0. So to find our average rate of change, they always give you the two x values. You've got to use your table to find the y values that go with it. So when x is a negative 4, my y is a 6. So that's how I finish off that point. When x is a 0, what is my y? Negative 6. So that's how we get our 2 points. We just use our slope formula now. Y minus y over x minus x. So negative 6 minus 6 over 0 minus a negative 4. So negative 6 minus 6 gives us negative 12. Subtracting a negative 4 means I'm really adding 4, so I get a 4 in the bottom. Negative 12 divided by 4, negative 3. So let's take a look at the back. We got another example here. They want us to graph this, which is negative x minus 2 squared plus 4 for the domain of negative 1 to 5. So again, they gave us the domain. So that means you've got to create a table where your x's are going from negative 1 to 5. The other thing that happens, since they gave us this domain right here, you're not going to have any arrows on your graph, because they only want to see that graph from negative 1 to 5. They don't want to see any other parts of that graph, so that graph does not continue at that point in time. So if you have not already done so, please type this into your calculator. Negative x minus 2 squared plus 4. Just like it's written on the paper with the parentheses and everything. Won't let you graph it. So let's go to our table if you have not already done so. We're going from negative 1 to 5. So on mine it's already showing, so you got to copy your y values down into your table. So this table is a little different from our last table. This has a middle number where that y value is not repeated. We're going to talk in a minute about what that is. So go ahead, plot your points if you haven't already done so. Again, there's no arrows on this graph because they gave us a domain. That's what we call a restricted domain. So you should end up with a graph that looks like that, and you label it. I should not see any just random U-shapes drawn on there. You have points. You need to plot them and make it specific. All right, so let's go through our questions over there on the side. Roots/zeros. We have how many of them? 2. No. It tells us to label them, so let's label them R1, R2. Our roots are x equals 0 and x equals 4. You do not write them as points. It's only the x values of that point in time. So 0 and 4. Our axis of symmetry, they want us to indicate it with a dashed line. Again, that is the imaginary line that goes right through the middle of your parabola. This one falls nicely on one of our integer values there. I label it as AOS, axis of symmetry. It goes through the x value of 2, so it's x equals 2. Our vertex, they want us to label it with a V. Right up there at the top of the graph. It would be the point 2, 4. Now the other thing they'll ask you sometimes is whether your vertex is a maximum or a minimum value. In this case, it would be a maximum because it's the highest point on your graph. There's nothing that's going to be higher. Our last graph, that first one we drew on the front, that one would have been a minimum because it's the lowest point. Nothing's going to be lower than it. So before we get to the next question, I want to go over a couple of things with your table. Your table is extremely helpful to help you find these pieces of information. For example, your roots and zeros are when your y values are 0. So if you look at your table, there's your 2 roots, 0 and 4. Whenever your y is a 0, that is also a root. So you can get those values from your table as well. The middle part that I boxed in here, that gives you your axis of symmetry if you look at the x part of it. But then the point together is your vertex. Your vertex is the point 2, 4. So that's why one of the reasons why we always find the pattern is it always gives you your vertex and your axis of symmetry right there in the middle. And the thing that's always going to happen is your axis of symmetry always goes through the vertex. Always. Okay, so they want us to find the value of f of -1. So remember, we always have an x in there. So what we're trying to find is what is the y value when x equals -1. So if we go to our table where x is -1, what is our y value? -5. Again, that's just something from our functions unit. Then they want us to find the average rate of change. That's what ROC stands for. That's small shorthand for rate of change. For -1 to 2. So again, they've given us the 2 x values. -1 is the first x value, 2 is the second one. We have to finish off the points. So it's the point -1, -5, and then the point 2, 4. And now we do our slope formula. So y minus y over x minus x. I start with my bottom point, subtract the top point from it. So minusing a negative means we're really adding. So 4 plus 5 is 9. 2 plus 1 is 3. 9 divided by 3 gives us a 3. And I believe, yeah, last one for our notes. I want you to type it in your calculator. See if you can find the table of values. They didn't give it to you this time, so you got to find the pattern in your y values. Alright, so you should get a graph that looks like mine up front, going from -2 to +4 in your x values. They did not give you a domain this time, so you need to have arrows on your graph, and then you've got to label it. You will lose points if you don't have arrows when you need them. We're going to go through that in a second. You got to remember to label your graph for these different parts when they ask for it. So your two roots would be at -2 and +4. And you need to have those labeled with R1 and R2, just like the directions tell you to do. Your axis of symmetry. An imaginary line that goes right through the middle. X equals 1, and again they tell you indicate it with a dashed line. Your vertex is down here at 1, -9. Is our vertex a max or a min this time? Min, because it's all the way down at the bottom. Then our last part, our average rate of change. -1 to 2. We got -1, -5, and then 2, -8. So we subtract y minus y over x minus x. So I get a -3 over +3. So my average rate of change would be a -1.